The sum is given by, so we have s equals 1 minus 2 times 1 out of 3 plus 3 times 1 out of 3 square minus 4 times 1 out of 3 whole cube and so on. So we need to write an expression for 1/3 s. So 1/3 s I can write as, if I were to write it right here, so 1/3 s would equal to 1 out of 3. So multiplying it, the whole expression by 1 out of 3. So 1 out of 3 minus 2 times 1 out of 3 whole square plus 3 times 1 out of 3 whole cube minus 4 times 1 out of 3 to the power 4 and so on. So next they are telling us we need to add s plus 1 out of 3s. So that is going to be, so s plus 1 out of 3s, of course that is 4 out of 3s, and that equals so we need to read the rest of the question where it says we need to describe the resulting series and find its sum to infinity. So most likely it's going to be a geometric sequence, so we need to combine the terms which will help us get there. So if we were to combine, look at the powers of 1/3 and put similar powers together. So what I mean is 1 out of 3 and 1 out of 3 put together, and 1 out of 3 square and 1 out of 3 square we put together, and the cube terms we put together, and so on. So then what I would get is the 1, I keep it as it is on its own, so 1 and then minus 1 out of 3 times, there will be 2 here and there's a 1 here, so it's 2 minus 1, and then plus 1 out of 3 square, and then I've got a 3 here, so 3 and then minus 2, and then I've got a minus 1 out of 3 cube, and then I have cube term is here, so I would have 4 minus 3 and so on. Okay, so you see this becomes 1 minus 1 out of 3 plus 1 out of 3 square minus 1 out of 3 cube and so on. So what we get is a geometric sequence. So this is a geometric sequence with a common ratio would be minus 1 out of 3. That's why the square terms are positive. Common ratio equals minus 1 out of 3. Okay, so that is the resulting series. So sum to infinity, now we know how to do that. Sum to infinity, we know if we have s infinity, the sum to infinity is given by first term divided by 1 minus the common ratio, so 1 minus r. So that would be equal to, we'd have a here as 1, and then the common ratio is 1 out of 3, so it would be 1 plus 1 out of 3, and that is minus 1 out of 3, sorry. So you know the minus and minus would give you a plus, so that would be 1 minus 1 out of 4 out of 3, so that would be 3 out of 4. So the sum to infinity, that would equal 3 out of 4. That's s infinity. So s infinity is 3 out of 4, and that's the answer. So next, so therefore, if I sum to infinity, then okay, so we can also say that, you see, s plus a 4/3 s So then we write that therefore 4/3 of s, the sum to infinity, is 3 out of 4, and therefore s equals 9 out of 16. Okay, then what we need to show is the part 3 of the question, and for the part 3, what they're telling us is we need to expand this 1 plus 1 out of 3 to the power minus 2 and use this result to confirm the value of s you found in part 2. Okay, so let me write down somewhere what s is. So we found that s infinity is that. So we found what s is. So we got s is 9 out of 16, and we got this. So let me erase this to make some space and expand that term. So 1 plus 1 out of 3 to the power minus 2. The thing is, it's a negative power. So the binomial expansion, if we were to write 1 plus x to the power n, would give us 1 plus nx plus n times n minus 1 to factorial 2 times x squared plus n times n minus 1 times n minus 2 times factorial 3 x cubed, and so on. So in this case, we replace n is minus 2 and x is 1 out of 3, and we continue the expansion. So we can write 1 plus 1 out of 3 to the power minus 2 is 1 plus 1 out of 3x. Sorry, x is 1 out of 3. Sorry, 1 minus 2 plus minus 2 and 1 out of 3, and plus, then it's going to be minus 2 times minus 3 by factorial 2, and then 1 out of 3 square, and then plus minus 2 times minus 3 times minus 4 divided by factorial 3 times, why am I writing x? Instead of x, it's 1 out of 3 cube, and so on. And that would give you 1 minus 2 times 1 out of 3, and then 2 and 2 goes, so we're left with plus 3 times 1 out of 3 square, and then minus, so 3 times 2 is 6, so we get minus 4 times 1 out of 3 cube, and so on. So you can clearly see that this term, this expression, is similar to what we had in the sum of s. So this confirms. So this yeah, so we have the answer. So we've done 1, 2 and 3. Thank you so much for viewing. Thank you for your time, and please subscribe and visit my channel at IPShiaMath147 for more maths problem solving videos. Thank you so much.